Welcome. So let's do a little review, and we'll look at some of the steps for graphing a rational function. I have the function graphed. I chose this one just to kind of review finding slant asymptote, finding x-intercepts, and then finding domain and range. Some things to note, though. First, horizontal asymptotes describe the behavior at the ends of a function. They do not tell us anything about the function's behavior for small values of x. Therefore, if a graph has a horizontal asymptote, it may cross the horizontal asymptote many times between its ends, but the graph must level off at one or both ends. Right? And so where it's going to cross is for the small values of x, near 0. The graph of a rational function may or may not cross a horizontal asymptote, but the graph of a rational function never crosses a vertical asymptote. And now, why is that so? Now let's think. So the values of the vertical asymptote don't actually exist. They are undefined. We have 0 in a denominator, and so that is not a true value. So those points, they just don't even exist. And so that's why our function cannot cross a vertical asymptote. Right? The horizontal asymptote is the end behavior of our graph as x approaches infinity and negative infinity. But the vertical asymptote are values where the function just does not exist. So let's fill in some blanks together. So the graph of f has vertical asymptotes. So let's think, where do we have our vertical asymptotes? Well, it's for values, and I should put values of x. And actually, let me rewrite that just a little bit, because that my u and my e just kind of blended together there. Values of x that cannot be reduced or canceled. I like the word canceled. That make the denominator equal 0. So if we can cancel it, it's going to be something else, right? It's going to be a whole, right? But if we can't cancel it, then it's going to be a vertical asymptote. Either way, we can't use any value of x that makes the denominator equal 0. The graph of f has at most one horizontal asymptote as follows. So so here I used n and d for numerator and denominator, but this here is still referring to the degree of the denominator. Here I used a d, but usually it's called n. But either way, it's the same thing. And this is the degree of the numerator. All right, so if the numerator has the smaller degree, then y equals 0 is a horizontal asymptote. And remember, if we add something in, then it's y equals whatever we add in, y equals c. Right? I'll put that too, y equals 0 or y equals c. And that's just if a value is added in. If the numerator and denominator have the same degree, then the horizontal asymptote is y equals a over c, where a and c are the coefficients of the leading terms, respectively. All right, so it's the ratio of those coefficients. Right? And what happens if the numerator has the larger degree? Well, then the graph is not going to have any horizontal asymptote. So if n is greater than d, then the graph of f has no horizontal asymptote. It has a slant asymptote instead. All right, let's look at one more graph. Oh, and so I hope this was a good review for you. If you want, you can, make a copy of this, and it will get posted if you wanted to print it out or write it down. So let's review slant asymptotes. All right, so step number 1, we're going to factor the numerator and denominator if it can be factored. The denominator is just an x plus 2. We can't factor that, but we can factor the numerator. All right, so a is 3. B equals 1 and C equals -4. 3 times -4 is -12. So we need two numbers that multiply to give us -12, but add to give us the B term of 1. Right? And I hope you are realizing that that must be -3 and 4. Right? Those would multiply to give us 12 and add to give us 1. So for factor by grouping, we keep the 3x squared. We replace the x with a -3x and a positive 4x because that's what they were before somebody went and added them together and made them in just an x. And we keep the -4. And the first two are a group and the second two are a group. And we can pull out, so all we're doing is undoing the distribution process, right? Undoing when somebody multiplied, right? So the last step they did is they added it together, right? Before that, right, they distributed. So we're going to undistribute. Right, so the greatest common factor for 3x squared and 3x would be a 3x. 3x squared divided by 3x is x, and -3x divided by 3x, that'd be -1. And greatest common factor for 4x and -4 would be 4. If we divide both of those by 4, we have x minus 1. So we can factor out the repeating x minus 1, and 3x plus 4 is the other factor. All right, so we could rewrite this as x minus 1, 3x plus 4, all over x plus 2. And notice nothing to cancel here, right? So we know we have a vertical asymptote. We also have a couple x-intercepts. So a fraction equals 0 where the numerator equals 0. So we can set the numerator equal to 0 to find the x-intercepts. Right? So that means we're going to set each factor equal to 0, x minus 1 equal to 0, and 3x plus 4 equal to 0. If x minus 1 is 0, x is 1. So 1, 0 is one x-intercept. We'll subtract 4 from both sides, so 3x equals -4, and then divide both sides by 3. So we have x equals -4 thirds. So that means the other x-intercept is -4 thirds, 0. So those are our two x-intercepts. We can also find, I don't have it written here, but we can find the y-intercept. So let's find the y-intercept. And to find the y-intercept, you just plug in 0 for x. Right? So we would have 3 times 0 squared plus 0 minus 4 divided by 0 plus 2. That's going to be -4 divided by 2, or -2. So the y-intercept is 0, -2. Now that's a nice point. We should use that one. So we already have 3 points. And I actually have it graphed on the next page. We actually needed more points than that just because of the shape of the graph. All right, so now we want to find the vertical asymptote. That's really easy. Just set your denominator equal to 0. So x plus 2 equals 0. X equals -2 is the vertical asymptote. And now for the slant asymptote, we need to use long or synthetic division. Since we've seen long a couple times, and we saw long in the last video, I'm just going to use synthetic here, but you can use either. All right, so for our divisor, we set x, x plus 2. I had to make sure I was looking at the right thing, what we're dividing by. X plus 2 is our divisor. It's what's in the denominator. So we set x plus 2 equal to 0. X equals negative 2 is what we're going to be dividing by. Same thing as the vertical asymptote. All right, and we're dividing into 3x squared plus x minus 4. So everybody's represented. We got a squared term, an x term, and a constant. Just need to list the coefficients. So 3, 1, and negative 4. Bring down the 3. 3 times negative 2 is negative 6. Add, we get negative 5. Negative 5 times negative 2 is 10. Add, we get 6. All right, so now this is the remainder, and we don't care about the remainder when we are finding the slant asymptote. This is a constant, we care about that one, and this is x. So our slant asymptote is y equals 3x minus 5. Okay. On the next page, I have the vertical asymptote, slant asymptote, x-intercept, y-intercept, all graphed, as well as some other points to help graph the function. So I'm going to show you the graph, and then we're going to do domain and range. This graph barely fit in, and I had a scale of 20. All right, so the first thing you can see there could be straighter, but here is our slant asymptote. This is the line y equals 3x minus 5. All right, so there's our y-intercept for the slant asymptote of 5, right? And then it has a slope of 3, so up 3 to the right one. Right? Our vertical asymptote is right here. That's x equals negative 2. Right? And so we have our x-intercepts, negative 4/3, 0, 1, 0, and our y-intercept, 0, negative 2. Right? And then we needed some points in between on the other side. So 3 of the points were to the right-hand side of the vertical asymptote. Notice, I'll make this in a different color. Notice how they make a U shape. All right, so it's going to be in between those two arms of the X there. It's kind of just nestled in there, right? And so it has to go back to the vertical asymptote, and it has to go back to the slant asymptote. At the bottom, when I plugged in negative 3 and negative 4, I got the same value, negative 20. And what this function will never do is go horizontal. So there has to be something in between, right? And so I needed to know what was in between those 2 points. And so I plugged in the halfway point, negative 7/2, and we got negative 19.5. So the graph again makes that little U shape, and it is just fitting on that graph. Just managed to squeeze that in. All right, so that's what our graph looks like. Let's do domain and range, because the graphing on this is not really that difficult. When you graph the vertical asymptote and you graph the slant asymptote and you graph your points, right, you see where to connect, right? So if you're not on the outside of the X, then you're nestled inside the X, right? And you're going to, just go back to the asymptotes. Those asymptotes are almost like guidelines. Let's do domain and range. So domain, of course, is everything but the vertical asymptote. So negative infinity to negative 2, negative 2 to infinity. Now this has an interesting range because look at, there's nothing in between, and I don't want to color all over it, but oops, I did not want a circle. Sorry, I wanted a rectangle, a new shape. So there is literally, there we go. Like nothing in between here. Notice I have no graph. I have asymptote, but no graph. All right, so I just kind of put that there so you can see, hey, no graph there. So we're coming from below, so negative infinity, and our graph turns around at negative 19.5. And because it's halfway between those 2 points, I feel really confident that probably negative 19.5 is a relative max in that little section of the graph. I put a bracket because we do go through the point. Our graph picks up again. Right? Doesn't pick up again until that low point there, and that's at 0, -2. So our graph picks up again at -2. Again, we go through the point, so I can put a bracket there. And then we keep on going to infinity. So notice there's nothing here between -19.5 and -2, and my range should show that. Okay? So this was just a little guideline to help you figure out that, hey, there's no function there. And I'm going to actually get rid of that because I don't really need that there. Let's see if I can get it to leave. But that's the end of this part of the graph, or this part of the podcast, and the end of graphing rational functions with slant asymptotes. So next we'll be looking at graphing rational functions with holes. Thanks for watching. Bye for now.